All right, people, let's start talking about allergies. Lecture at 5. Now, let's start by defining allergy first, okay? So an allergy is an inflammatory response to a non-pathogenic antigen called an allergen. Now, what does that mean, okay? Which means that things that you're allergic to, we call them allergens, and we call them non-pathogenic because of the following. A true pathogen, right? Bacteria, viruses, so on and so forth. They make everybody sick, okay? However, allergens don't make everybody sick. Allergens only make people sick who have sensitivities to that specific allergen, okay? Now, there's 2 types of allergies. You can have something called immediate hypersensitivity, right? And this is all mediated by antibodies. And look at the name. It occurs in minutes, right? So when I go outside to take a walk with my daughter, I'm already getting itchy eyes and I'm starting to sneeze, okay? So this happens now, okay? Now there's something called delayed hypersensitivity. This takes several days. You can now be exposed, but you don't have an allergic response until days later. And this is not facilitated by antibodies. We're utilizing now CD4 cells and macrophages to turn on this delayed hypersensitivity response. Now, I do briefly want to talk about anaphylaxis. So it's not of a branch of the allergy, but anaphylaxis is when you have a body-wide allergic response, right? And so it is kind of the branch of hypersensitivity, immediate hypersensitivity, but it is mediated by antibodies called IgE, okay? And so if you have a body-wide immediate hypersensitivity response, you get the hugest amount of release of histamine, and that can cause you now to have bronchoconstriction, this hard time having hard time breathing, hard time getting air into the lungs, and then also vasodilation, which is not good. Is because what happens now is that you start to vasodilate all your major arterioles, and then you get blood flow everywhere to the peripheries, right? So to your arms and your legs, and you start to lose blood away from your core and away from your brain because it's getting shunted throughout the rest of your body. And then in this case, you can go into shock. So this is dangerous. So here's some pictures of some common allergens. Of course, there's good old pollen. And a lot of you folks have allergies to the pollen in the area. And then there are dust mites. Look at this beautiful dust mite here. And interestingly, we are allergic to its poop. Yes, it's poop. Because if you think about allergens, in order for them to cause an allergic response, they have to get inside our bodies, right? They have to break through the mucosal layer. And so there's enzymes in that poop that allow us to kind of break through the epithelial layer so that we can now be exposed to cells that launch an immediate hypersensitivity response. Now, for some allergies, you can be born with that allergy. You've inherited it from your parents. But with some immediate hypersensitivity allergic reactions, you develop them over time, and you have to be exposed to them multiple times, and then your body develops a hypersensitivity to it. Okay, so for me, I'm allergic to cats, and I wasn't always allergic to cats, but after being exposed to cats over time, I remember I was playing with a stray cat. I was older already, I think 8. I remember playing with a stray cat outside, and I mean, I've always played with cats, and then I remember that day, like I had a major asthma attack and I was wheezing, and then all of a sudden I had a hard time breathing and I was sneezing. It was very scary, but I had developed that over time. And cats, interestingly, when I ask people, what are you allergic to with cats? Oh, their fur. Oh, they're dander. Well, what the hell is dander? I don't even know what dander is. Dandruff? Is that what it is? But anyway, it's their spit, right? It's because they're licking their fur and their spit has enzymes, and that's the thing, that's the allergen in for cats. It's their saliva, the enzymes in their saliva. This is how you get tested if you have an allergy for a particular allergen. So what you folks are seeing here on this left picture is you have now the essence of, this is soybean, apple, hazelnut, nut milk, strawberries. And what you're doing now is taking the oils or just ground up substances from these, from what I just read off, and you're making scratches, right? You're making scratches in an arm, or sometimes people get it done in their back, and then you wait a little bit, and then if you get an inflammatory response, yes, then you know that you have now a hypersensitivity to that specific allergen. Now, this is the mechanism for immediate hypersensitivity. So the first thing is when you're exposed for the first time, right? Dendritic cells, so remember, dendritic cells are those specialized macrophages, right? So they're going to take in the allergen, and they can now stimulate CD4 cells if CD4 cells in your body have a TCR that can bind to that allergen. Okay. And then what happens is, in doing so and in activating those CD4 cells, you now have CD4 cells that can stimulate B cells if these B cells have an IgE antibody that is specific for that allergen. Okay. And this is why allergies can either be inherited. You already have the propensity to make these specific Toll cell receptors, T cell receptors, and also these IgE antibodies, or they can be developed over time. Okay. Now, once the B cells secrete IgE, these IgE antibodies can now bind to mast cells. Okay. So mast cells have histamine vesicles in them. You see these here? They're all filled with histamine. Now, once you've now primed the mast cell, and what that means is now you have IgE for a specific allergen just sticking on all your mast cells, what happens is when you get re-exposures, right? This is to the same allergen. What's going to happen now is that allergen is going to bind to the specific binding sites on the light chain of this IgE antibody. And in doing so, it's going to now cause the mast cells to release histamine, leukotrienes, prostaglandins, right? So your nose starts to run because you have that. When your nose runs, you're having an inflammatory response, right? So you start to sneeze, so on and so forth, right? You're having an allergic reaction. Now let's go over the mechanism for delayed hypersensitivity. So the mechanism here starts off with T helper cells, aka CD4 cells. And if you have an allergen, something like poison oak or poison ivy or sumac, and what these are allergens. These are plant oils that can get in through the skin. And what happens now is if you have a CD4 cell whose TCR receptor can bind this allergen, right, is that they're going to secrete some type of cytokine, and I don't care that you folks know the exact name. Cytokine, that's fine. Okay. And what's going to happen is this cytokine can now turn on macrophages and T killer cells. Okay. And this takes more than 24 hours. This takes a while, right? And so what's going to happen here is any cell that now contains this allergen, you're going to lyse these cells. These T killer cells are going to secrete their perforin molecule to poke holes and kill these cells, and your macrophages are going to eat them. And so what's going to happen now is that you start to get these blisters, and it's very, very red. I got this from online. I hope I don't get in trouble for hijacking it off the web. But this is what these types of allergies look like, and they are delayed onset. I'm going to wrap up Lecturette 5 by talking about stress and immune function. And so what you folks are looking at right here is immune function, and this at this line is 100%. And on your x-axis, this is the stressor, how long the stressor is, right? And so this is the onset of your stressor. Oh no, we gotta start studying for exam. And then the stressor is there, and what happens initially is the stress, because cortisol allows you now to break down simple sugars, right? Allow you to have carbohydrates and simple sugars and other monomers. You get a bump of immune function. However, as the stressor is prolonged, right? Test after test after test after test, immune function starts to drop, is because of prolonged cortisol secretion, right? And so what glucocorticoids do is they can inhibit T helper cell response and the inflammation response. And this is why we take or apply hydrocortisone cream when we have an itch, is because it lets inflammation go down. Okay. Or also for organ transplants, right? So if you have an organ transplant and you are now having cells that are secreting, or not secreting, but have non-self antigens on the MHC1, you take now prednisone. Prednisone is a very, very strong type of glucocorticoid, okay? And you have to take it for life. It's because you have to quiet down your immune system so that you don't launch immune response against the donor organ. All right, that's it for this lecturette. Whee! And we're going to move on to our last lecturette, vaccines.